Guys, I told you I'd do number 11 if you needed a little more help with the piecewise functions. And so here's number 11 up here. A function is g of x, and you can changing its shape in each of these three different portions of the graph. It's kind of important with a piecewise that you kind of look at these before you even start. Just kind of glance and know what this is going to make before you start. It'll help you out. So 3x plus 12 is linear, which means I'm going to have a line in this section. It's going to be going uphill because the slope is 3. So just kind of get that general shape in mind. In between negative 3 and 3, I'm going to have the absolute value of x. So we talked yesterday about how that makes that V shape. And I'm going to have that in between. And then down here, when I'm greater than or equal to 3, I've got almost the same that I had up here, only my slope is now negative. So I'm going to have another line. It's going to be going downhill with the same slope as this one, just so you kind of get an idea how that's going to work. I'd also take into account the inequality symbols that you can see here, because that's going to tell us something about our graph. So when you're struggling with these, it's often helpful to go and put kind of a barrier or a fence on each of the constraints. So right here, first I have negative 3, so I'm going to just put a light fence here. And you can just do that dotted or pencil or visualize it. But I've got a fence at negative 3, and what I'm telling you is I'm going to have a line going downhill everywhere to the left of negative 3. We'll deal with that later, or equal to. In between negative 3 and 3, so I'm going to put another fence right here, is where my absolute value graph is going to go. And then the last one is greater than 3. So I've basically got my graph chopped into 1, 2, 3 sections by those two fences. The next thing I would do is decide if you live on the fence or off the fence. And that kind of tells you this inequality. This one, I get to live on the fence. This one, I'm going to keep open because it says less than right here, not less than or equal to. And on this one here, I get to fill it in on the fence. So notice I really haven't done anything yet, but this does kind of help break these into their different pieces, hence the name piecewise function. So let's start right here with my 3x plus 12. You are going to go on each of these and you're going to plug the fence in or the boundary in, and then you will either leave it closed or open depending on whether you get to live on the fence. So for this one, when I put in a negative 3, I'm going to have 3 times negative 3 plus 12, which is equal to 3. So at negative 3, I'm going to go up to 3, and I get to live on the fence. So you're going to fill that dot in. Had that been just like this, I'd leave that dot open, but you always plug the boundary in because you can get right up to it. Here you don't touch it, but you can get up to, like on this part, 2.99999999999. So you still need a dot there. You just need to decide whether you get to live on the fence or off. So in this portion of the graph, I need to have a line with a slope of 3. So again, but I need to be to the left of the graph. So sometimes it's helpful to think, well, I know slope, I go up 3 over 1, but I'm not going in that direction. So I'm going to go down 3, back 1, and I'm going to go like this. Forever less than or equal to negative 3, that's my piece of the graph. If I had continued this green line in between the fences, I would have hit 0, 12 because that's the y-intercept. So that looks good. I've got my line. It's downhill. I lived on the fence. Okay? Oops, sorry about that. All right, so the next part. In between the fences, I'm the absolute value of x. Everything in between negative 3 and 3, I need to take its absolute value. Well, keep in mind, that includes 2.999999999. So I go to the fences, and I say, okay, I'm going to plug in a negative 3. Its absolute value is 3. So I go to negative 3, 1, 2, 3. And normally I'd leave it open, but it already closed with the other function. So there's still a closed dot right there. Over on the other side, at the other constraint, I would take the absolute value of 3, which would be 3. And I'm going to leave that open. Okay? So in between there, I do my absolute value function. 1, 1, 2, 2. It looks like that in the middle piece. And now for my last fence over here, my last piece, I've got a graph, negative 3x plus 12. Well, again, I plug that boundary in. I do negative 3 times 3, which would be negative 9 plus 12. And I get a 3. Sorry, my phone's ringing. So at 3, 3, I go there, and I get to fill it in now because I get to live on the fence. So that's it. I'm done. This would be called continuous because when I sketch each graph, I never have to lift my pencil.